Hi guys, we're on to video 2 of our unit circle project, and we're going to be adding our 45-degree angles onto our unit circle with this video. So I've made a little triangle that fits here and creates a 45-degree angle, so it goes halfway. So I've measured this to be 45 degrees. This is 90 degrees, so it's a right-angled triangle, and 45 degrees. Okay, we're going to talk about this a little bit. I'm going to remove this, and I'd like you to take some notes on this, please. So we're going to take this triangle. Notice the only length we would actually really know right now about this triangle is its hypotenuse, because that hypotenuse is a radius of our unit circle. Since it's a radius of our unit circle from the center out to the edge of our circle, then that has to be 1 unit, okay, because it's a radius. All right, so let's talk about this special triangle right now. This is a special triangle, one of these special triangles, okay? It's the 45, 45, 90 triangle. And so 90 degrees here, this is 45 degrees. Which means that this up here also has to be 45 degrees. Okay, the only thing we really know, because we've drawn this on our unit circle, is this hypotenuse has to be 1 unit long because it's a radius from our unit circle. Okay, so we could use Pythagorean theorem, c squared equals a squared plus b squared, to figure out the lengths of these other 2 sides of the triangle, because it's an isosceles triangle. Isosceles triangle, which means 2 sides the same length, which also means that there's 2 angles that are the same size. Okay, so since both of these sides are the same length, let's call both of them b. Okay, since a equals b in this case, because it's an isosceles triangle, we can say c squared equals 2, well, let's say, I'll just call them both a. So a squared plus a squared, because a and b are equal. So c squared equals 2a squared. Okay, we know that c squared, our hypotenuse, is equal to 1. C is equal to 1. So 1 squared equals 2a squared. All right, let's just do the algebra and solve for a. So 1 equals 2a squared. I prefer to have it written on this side, so our unknown is on the left. Divide both sides by 2, and then square root both sides. So this a equals the square root of 1/2. Okay, what happens when we simplify that? A equals square root of 1 over square root of 2. Square root of 1 is 1. Square root of 2 we can keep like this. Okay, so this is a good number here. This is a good length, 1 over root 2. It's an exact length. If we want to rationalize that denominator, which means get rid of the root sign in the denominator, we would multiply by root 2 over root 2. Remember, we did this at the beginning of the year when we talked about radicals. This is multiplying by the number 1, so it actually doesn't change the value. It doesn't change how big this number is, because we're multiplying by the number 1. That number 1 just looks like root 2 over root 2. So when we do this, we multiply across the numerators, root 2, multiply across the denominators, root 4. Well, we know root 4 is 2, so this is root 2 over 2. And that's the form of the number that we're going to use, okay? So this is also 1 over root 2 is a fine form for that number, but we're going to use this one here, root 2 over 2. They're exactly the same number. If you type them in your calculator, you'll see that. Okay, so this length is root 2 over 2, and this length is root 2 over 2. All right, so that's good for your notes. Let's go back to the unit circle. So add this to our unit circle. So we know that, here's my little triangle again. We know that the radius is 1, so that length is 1. We now know that this length is root 2 over 2, and this length is root 2 over 2. That then tells us that we have we want to know the ordered pair, oh my goodness, having trouble getting my marker top off here. We want to know the ordered pair for this position right here. Well, it would be, the x-coordinate would be this length, so that's root 2 over 2. And the y-coordinate would be this length, so that's also root 2 over 2. Okay, so we have root 2 over 2, root 2 over 2 for that ordered pair. All right, we can draw that radius on there, and that represents, please use your ruler to do a good job. Let me grab my ruler. Good job on there. 45 degrees, there we go. Now, let's continue and put the rest of our 45 degrees on here. There's my 45s. Oh, and this is where we want it to use colors. So instead of using black, I could be using my blue. Okay. So I'm gonna make my 45s blue. All right, so there's 45 and 45 in the other way, halfway between again. Try to be as accurate as you can. If you do have a protractor, you could even use it. Okay, so this would be dividing our unit circle into 8 equal pieces. If we divide them into 8 equal pieces, each of them is pi over 4, or you could think of them as 45 degrees. Okay, now, as we go around this unit circle, as we go around to put the rest of our ordered pairs on, we see that this ordered pair is root 2 over 2, root 2 over 2. Now let's come across here, straight across to this one. It's the same height as this one over here, which means that the y-coordinate is the same. Okay, I'll put that on in black and just underline it. So the y-coordinate is root 2 over 2. And the x-coordinate, let's see, we can show this even using my little triangle. Here's where the triangle was here. It's actually this way, so it flips in the y-axis. Okay, so it's symmetrical about the y-axis. And now this same distance here is root 2 over 2, but it's in the quadrant 2, so it's negative root 2 over 2 is the ordered pair there. So let's come down here. Let's then take this triangle, flip it down this way in the x-axis. Okay, and now we still see that's a radius of 1 unit. And each of these is now root 2 over 2 in length. But the x direction is negative, so negative root 2 over 2. And the y direction is also negative, so negative root 2 over 2. And then just take a minute and figure out for yourself. Stop the video and figure out for yourself what this last ordered pair would be here with our triangle in this position. Okay? And then come back and see if you got it right. Okay? Do some of that thinking. So this should be positive root 2 over 2 for the x direction, and in the y direction, negative root 2 over 2. All right, so there's our ordered pairs on for our multiples of 45 degrees. Now let's add our degrees and radians on. So we've already talked about all of these values. Let's just add our degrees and radians on. And we'll write those degrees and radians just beyond our ordered pairs because it's going to get pretty cramped in here if we start using in there. Okay, but please remember, these angles all start from our red initial ray and go counterclockwise in that direction. So each time we're writing a number, when I write this first number here, 45 degrees or pi over 4 radians, okay, they're both correct. That's from here up to here. Okay, then the next one was 90 degrees, pi over 2. Next one is, add 45 more, so 135 degrees or 3 pi over 4. Go again, another pi over 4, so that's 180 or pi. Go again from here, add another 45 degrees, so that's 225 degrees or 5 pi over 4. go again. That's 270 degrees, or 3 pi over 2, 6 pi over 4. And again, this would be 315 degrees, or 7 pi over 4. And then the last one, 360 degrees, or 2 pi. Oh yeah, and I forgot again to talk about 0. And if we start here and go nowhere, 0 degrees, or 0. Okay, that is that part. On to the next video. Thanks.